Hi class, today's lesson is exercise 8G, independent events. If events are independent, it means that the outcome of one event does not affect the outcome of the other event. For example, if I toss two dice, it doesn't matter what I get on the first die. It's not going to affect the number that's going to come up on the second die. So they are independent. However, if I draw two cards out of a deck of playing cards, I draw one at a time and I don't replace them. So what I draw on the first card then affects the outcome of the second card. Like if I drew a three of hearts like in this image and I don't put it back in, then it's not going to be included in the probability for the second card I draw. So these are not independent because the outcome of one does affect the outcome of the other. This is a formula to check if events are independent. What it means is the probability of A, given that B has already occurred, is equal to the probability of A occurring by itself. So the outcome of A is not affected by the fact that B has already occurred. Let's have a look at some examples and decide if the events are independent or not. So the first one, flipping a coin twice. Now I know I already told you that that is independent, but I just want to show you how we know. So on the first flip, I can either get a head or a tail. The probability of getting a head is 1 out of 2 and a tail 1 out of 2. Then on the next flip, I can either get a head or a tail and a head or a tail. Same probability, 1 out of 2. Okay, so let's have a go at applying the formula. Instead of using A and B, I'm just going to use H and T from here. So the probability of getting a head, given that tail has already occurred, equals the probability of getting a head. Okay, so that's the formula. Let's see. So the probability of getting an H, given that T has already occurred. So this is like T has already occurred. And the probability of getting H is 1 out of 2. Versus if we look at the probability of getting an H just by itself here, it is 1 out of 2. Therefore, because they are equal, this means that the events are independent. So the outcome of one doesn't affect the outcome of the other. Okay, let's have a go with this. Picking two mugs out of a drawer without replacement. So once you pick one, you don't put it back in. Okay, so the first mug, we can either get a red or a blue. The probability of a red is 2 out of 5 and a blue 3 out of 5. And on the next pick, so if I've already got a red, the probability of getting a red on the second pick is 1 out of 4 and the probability of a blue 3 out of 4. But if on the first pick I get a blue, then the probability of getting a red is 2 out of 4 and a blue 2 out of 4. Okay, let's have a go at applying the formula. So probability of getting a red, given that blue has already occurred, equals the probability of getting a red. Okay, let's see if the formula works. So the probability of a red, given that a blue has already occurred. So a blue has already occurred, that's this here. And then the probability of getting a red is 2 out of 4. And the probability of getting a red, that is 2 out of 5. Therefore, they do not equal each other. So they are not independent. Picking two mugs out of a drawer with replacement. So if we've got with replacement, we're putting them back in. So we're either getting a red or a blue where it's 2 out of 5 and 3 out of 5. And we're putting the mugs back in. So the probabilities stay the same. 2 out of 5, 3 out of 5. So write out the formula. The probability of red, given that blue has already occurred, equals the probability of red. So the probability of red, given that blue's occurred, so blue has occurred, and probability of red, 2 out of 5, and the probability of red occurring is 2 out of 5. Therefore, because they equal the same, these events are independent. This one's a little bit tricky to wrap your head around. It's similar to some of the ones on the problem-solving task. The probability of rain on any particular day is 0.2. However, the probability of rain on a day after a rainy day is 0.85, whereas the probability of rain on a day after a non-rainy day is 0.1. Okay, so we're going to draw a tree diagram. We've either got a rainy day or a non-rainy day. Okay, so the probability of rain on a particular day is 0.2. So this is rain, 0.2. So that means the probability of not rain. So these two probabilities must add up to 1. So 0.2 plus 0.8, that will give us the full probability. Okay, so then the probability of getting rain after a rainy day is 0.85. So after a rainy day, the probability of getting rain is 0.85. So that means after a rainy day, the probability of not getting rain, these have to add up to 1. So 1 minus 0.85 is 0.15. The last thing it says is the probability of rain on a day after a non-rainy day. So after a non-rainy day, the probability of rain is 0.1. So that means the probability of not getting rain is 1 minus 0.1, so 0.9. Okay, so now we've drawn the tree diagram, time to check the formula. So the probability of getting rain, given that it was a non-rainy day before, equals the probability of rain. Okay, so the probability of rain, given that it was not a rainy day before. So not rainy, and then the probability of rain, so 0.1. And the probability of getting rain, that was just 0.2. So therefore, they're not independent. So the outcome of one depends on the outcome of the other. You can also apply the formula to Venn diagrams to figure out if they are independent events. So we're going to find out if A and B are independent. So probability of A given that B has occurred equals probability of A. Okay, so probability of A given that B has already occurred. So B has already occurred, and the probability of A, that's like this part here. So the probability is 2 out of 5 versus the probability of A. So the probability of A, that's like this part here, which is 7 out of 10. So I've just added up the whole thing. So therefore, they don't equal the same. So the events are not independent. Last example. A selection of 14 hotel offers include 8 with free Wi-Fi and 9 with a free breakfast, whereas 3 offer both free Wi-Fi and a free breakfast. Summarise this information in a Venn diagram. Okay, so we've either got Wi-Fi or breakfast. So there's 3 that offer both, so 3 in the middle. Wi-Fi, there's 8 altogether, so 8 minus the 3 in the middle equals 5. Breakfast, there's 9, so 9 minus 3 in the middle is 6. Check that adds up to 14. Yep, it does. Okay. Next, we need to find the probability of W, or Wi-Fi. So that is 5 plus 3, which is 8 out of 14. And the probability of Wi-Fi given breakfast has occurred, W given B has occurred. So this is like B has already occurred. And the probability of W is that. So it equals 3 out of 9. State whether the events W and B are independent. So if I just write out the formula, which they've already pretty much written, these two things do not equal the same. So therefore, they are not independent. So the outcome of one influences the outcome of the other. Okay, I would now like you to complete the independent events worksheet.